Take your work out, compare what you got with what I got. Are there any questions, comments, or concerns? Is there anything there anyone would like me to go over? No, I am not going over all of them. Yep. For number 10? Yes, but you need to take that a step further, and because 2 to the power of 0 is 1. Take it one step further. Okay. That's down to 16. Any other comments, questions, concerns? At this stage, for a question like 12 and 14, either of these answers are correct. Either this one or this one. Either one. You don't have to have one or the other. Either is fine. Okay, are we good? Down to 16? Can I slide the...
Do we do 16 actually?
Sure. I will do question 16. Okay, moving down. Any of these questions that have multiple colored answers, either answer is correct. So like question 18, 19, 21, and 22, where I've got different colored answers, either one is correct at this stage. So question 22 has 3 different correct final answers. Compare what you got with what I got. Is there anything there anyone wants me to go over? Number 19. Yes, we can do number 19. Anything else anyone wants me to see? Yes, Quinn. 22. Anybody else wanted me to do any of those questions that are at the bottom?
Can we do 18?
You bet. Anybody else? Okay. Going once, twice, thrice, sold. Okay. There's a lot of conversation going on. Volume's got to come down, guys. Sam and Louisa, volume's got to come down. Okay, 16. Who wanted 16? Dea. Did you want question 16? Okay, stop talking to the people around you. Okay, Dea, there's a few ways we can go about dealing with this. We could simplify the numerator first, or we could do some dividing to get rid of some stuff. Which way would you like me to approach this question? Okay, cool. Is there anything in the numerator that is also found exactly the same way written in the denominator? X to the power of 2. So if I've got the same thing in the numerator and the denominator, I can divide it away. It's going to give me 1. And when there's a bunch of other stuff there, you don't have to put the 1. And if it's in the denominator, you don't have to put the 1. So now I've just got 2 times 3x. I just multiply those together, and what am I going to get?
You get 5.
No,
6.
I get 6. Done. That's question number 16. Who wanted question number 18? Layla. There's 2 ways you can approach to start this question. You can do some, if it's possible, we can always look to see if there's things in the numerator and the denominator that we can divide away. Or I could simplify the denominator. Layla, which way would you like me to start this question? Simplify. Okay, cool. If I'm simplifying, we're looking just at the numerator and just at the denominator. Is there anything I can group in the numerator? I've got a 4 and a p squared. Those are different. There's nothing else there. Louisa and Sam, stop it, please. There's nothing else to do. So let's go to the denominator. Do I have any same bases down there in the denominator? No. Are you sure? What's the base there?
3.
That's a 3. That's a... That's a 2, and that's a... I still got p's. I got p's in the same spot in multiple places in the denominator. So yes, I can group these p's together. When I have p squared times p to the no exponent written, no exponent written is the same thing as p to the power of what? 1, someone said. Fantastic. And when I'm multiplying bases, what do I do with their exponents? I add them. Yes, William. So p to the 2 times p to the 1 is going to give me p to the power of 3. 1 plus 2 is 3. The 4p squared stays up in the numerator. And in the denominator, I still have 3 times 2. When you have numbers and letters, you can multiply the numbers together. No one's going to stop you. In fact, I encourage it. 3 times 2 is? Okay. And now there are 2 simplifications that can be made here. Let's deal with the exponent one first. I have the same base here. The base here is p in the numerator and the denominator. I'm dividing them because it's a fraction. That's what it means. So when I'm dividing the same base, what do I do with the exponents? Subtract them. Thank you, Prob. And it's always top minus bottom. So 2 minus 3? -1. So I'm going to get a p to the -1 up top. And now I've got a 4 over 6. That's just a fraction. What do we do with fractions?
Divide the numerator by the denominator.
Yeah, but no. 4 and 6 are both divisible by?
2.
2. Thank you, Ikshat. Divide by 2, divide by 2. 4 divided by 2, Dea. 2. 6 divided by 2 is? See, and I don't mind busting your chops a little bit for that one because the rest of the test is going so well for you. But on that very first question, you're never going to live that down. The very first question you ever did for me on a test. 4 divided by 2 is 1. We're going to make that same mistake on the very last question on your final exam. It's going to be great. Okay, so, Layla, that is a totally acceptable final way to leave this question. Does that make sense? The procedure is good? Okay. You'd say if it wasn't? Maybe? Okay. Who wanted 19? Eve, here we go. Eve, same question. I can make some simplifications in either the numerator or the denominator, or I can see if there's any dividing to happen to cancel stuff out. Which way would you like me to start? Okay, simplifying in the numerator and the denominator. Okay. So, do I have any same bases in the numerator? So are any of those the same thing? No. So there's nothing to simplify in the numerator. Do I have any same bases in the denominator? Uh, 2u is not a base. 2 is a base, u is a base, 3 is a base, v is a base, and u is another u base. You have to look at them individually. So, do I have any same bases down here in the denominator? 2, u, 3, v, u. No, you said 2u. Oh, you mean that there's 2 different u's? Because you just said 2u. Oh, so do you see how I was confused by that? Yeah, so yeah, the u's. Sure, that's u's. When the u has no exponent, what's the exponent? Okay, Prisha, you're getting louder. I know you've been whispering. Maybe you've been helpful. I don't know if it's been helpful or social. But I let it go while the volume was low. Turn the volume back down or stop it. When there's no exponent written, what's the exponent, Eve? It's a 1. So let's put it in there. So we can start grouping things in the denominator. I can do the 2 times 3. 2 times 3 is? Okay. What's u to the 1 times u squared? Not Eve. Yes. U to the power of 3. When I multiply same bases, I add exponents. And there's nothing going on with that v, so I leave the v there. And now in the numerator, I still have v times 3u squared. Each numerator and denominator is as simple as it gets. So now I have to start seeing if I can deal with things vertically. I got a v in the numerator. Does v show up anywhere in the denominator? Yeah. And they're exactly the same. When they're exactly the same, what can I do? Bam, bam. Leaves me with 1. Okay. Look, I got a u squared and a u cubed. Those are different, but the bases are the same. So what can I do when the bases are the same, but the exponents are different? What do I do with their exponents when I'm dividing? Yes, and it's always top minus bottom. So u squared over u cubed, 2 minus 3 is?
2 minus 3. 1. Oh no, minus 1.
Very good. So you take the base, you put it up top, and you put it to the power of negative 1. Those are dealt with. And now I've got 3 over 6. 3 and 6 are both divisible by? 3. 3 divided by 3 is?
1.
And 6 divided by 3 is? 2. And when I have something else written in the numerator, I don't need to put the 1 beside it. I could, but I don't have to. There you go. U to the negative 1 over 2. Right now you can. Next year, you can't. But this year, it's okay. Okay, Quinn, do you, after all of those individual questions, do you still need to see 22? You sure? So what I'm hoping is that you guys are getting to the point where you're like asking yourself the same questions I'm asking you. If you're struggling deciding where to start, ask yourself these questions. Is there anything I can cancel top and bottom, or should I simplify across the top or simplify across the bottom? Pick a letter and start. So Quinn, you're the one that wanted 22, right? And you're feeling okay about it? Verinder, you still want to see it? Huh. Verinder, where do you want me to start? I've done 3, and I've asked the same question each time. Where do you want me to start, Verinder? What do you want me to do with the letters? Did you attempt this question, Verinder, or did you leave it blank? Okay, so where do you want me to start? What letters? Okay. Which y's? The ones in the numerator or the ones in the denominator? Dea, stop being a disturber. Dea, put your head back down. Now I can't see Verinder. The y's in the denominator? Because there's nothing to do in the numerator, right? Okay, here we go. So the numerator stays the same. It's 2y squared. Verinder, I've got y's there, there, and there. I'm multiplying them together. Each of them has no exponent written. So if there's no exponent written, what's the exponent? It's a 1. Boom, boom, boom. So what am I going to get with the y's there, Verinder? Y to the 3. Yeah, y to the 3. Good. So that's my y's dealt with. Boom, boom, boom. Let's move on to the x's because you said you wanted the letters done. So this x has no exponent written, so we're going to toss a 1 up there. And now I've got an x to the 1 times x to the 2 times x to the 2. When I'm multiplying bases, the bases are all x. What do I do with the exponents? Add them. So what's 1 plus 2 plus 2? X to the 5. My x's have been dealt with. And now I've got 4 times 3 times 2. 4 times 3 times 2 is? Thank you. And put that out front. Cool. I've simplified the thing. Now we need to deal top and bottom. So, let's go alphabetical. 2 and 24 both start with T. T comes before X or Y. So can I do anything with the 2 and 24? Both by? You bet. Divide by 2, divide by 2. 2 divided by 2 is 1. I'm not sure if there's anything going to be left there, so let's leave it out there for now. 24 divided by 2 is? Yep. And it's still it was in the denominator, so the 12 is going to go back into the denominator. Let's deal with the x's, because that's alphabetical. X comes before y. Are there any other x's in this question? No. So x to the 5 is just going to continue to stay in the denominator there. That's dealt with. That's dealt with. Now I've got those two. Y squared over y cubed. What do I do? Subtract the exponents. 2 minus 3 is? -1. So, and the result of which I throw into the numerator. So I'm going to get y to the -1 up in the numerator. Because 2 minus 3 is -1. And if I'm not mistaken, that was one of the 3 answers I gave you. It was the pink one. You're done.
Can I see the 3 answers again?
Brinder, does that make sense? Believe it or not, all 3 of those are the same. Fast. Fast. So fast. Like jog down the hallway kind of fast. You're not jogging. Okay, here we go. There's a half an hour left, and the lesson took me about a half an hour with the first block. So, listen fast. Here we go. There are 4 more exponent laws that we're going to do today, and then that's it. And you're going to have a bunch of homework practicing these exponent laws. Here we go. So, what does it take a hall pass? Forget the name for the hall pass. For now, I have to re-put my naming chart up there. Thank you, Iyad, for trying to do what I wanted you to do before. Okay, power of powers. Here we go. What this is, these examples are kinds of questions where you have something to a power. That thing is in brackets, and then on top of that, I've got it to another power. So to figure out how this is going to behave, my question to you is this. Look at this outer exponent here. That's a 2. What does it mean to square something? Dea. Multiply whatever you're squaring by itself. So what are we squaring? No. 2 cubed. So I'm going to take my 2 cubed, I'm going to multiply it by itself. This is going to become 2 cubed times 2 cubed if I start to expand this. But look. That looks an awful lot like an exponent law we did yesterday. I am multiplying same bases. What do I do with the exponents?
You add them.
I add them. Using yesterday's law, we'd say, oh, look, I can just add these 2 things together. 3 plus 3 is? 6. So I could rewrite this as 2 to the 6. Interesting. Look at what I started with, though. What could I have done with the 2 and the 3 here to get me 6 without expanding anything?
3 times 2.
Oh, yeah, Bosco, is that what you were going to say?
No.
Okay, Deo, you're right. If you look at the relationship here, I could have said, okay, well, I could square the thing, expand it. 2 cubed squared is 2 cubed times 2 cubed. Add my exponents together, boom. Or, as Dea has suggested, look what happens here. If I just multiply the 2 and the 3 together, I get the same result. Fascinating. Let's see if it works again. What does it mean to cube something?
Itself by itself by itself.
Itself by itself by itself. Okay, so I'm going to have 5 squared times 5 squared times 5 squared. Oh, look. Yet again, the bases are the same. So what can I do with those exponents? When I multiply same bases, what do I do with the exponents? Add them up. What's 2 plus 2 plus 2? It's 6. But look, no, stop doing that, Dale. It's not applicable here. Well, okay, so I got 5 to the 6. Oh, look. Same deal. If I'd taken these 2 numbers and just multiplied them together, I would have gotten the same result. Fascinating. Anyone want to take a guess at what's going to happen here?
It's x squared. So it'll be 2x.
Have a lovely
power of
weekend.
8.
I'm assuming you have to go right now. You're doing all of the things that make it look like you're leaving. Video will be up. Have a good weekend. Your homework will be 1 to 30 odds. Have a good weekend. Here we go. So x to the 4 squared. That's going to be x to the 4 times x to the 4. Same base. Add those exponents. What's 4 plus 4?
8.
8. But look.
It will be 2x
What could I have done here?
multiply 2 by 4.
I could have multiplied the 2 and the 4. I would have got the same result. So this is the law. When you have something to an exponent, and then outside the brackets you've got another exponent, a way to reduce this is to multiply the outer exponent with the inner. Anyone want to take a guess at what they think the last question should be?
Y 35.
It will be y to the 35. Nice and easy, right? Let's make it more interesting. Stop me if you've got questions. There we go. Okay, now I had power of powers. Now I've got power of a product. So now instead of just having one thing inside the brackets, I have multiple things inside the brackets. And those things inside the brackets are being multiplied together. So I've got a power of a product. What's it mean to square something?
Times the y.
Cool. So in this first row, what am I multiplying by itself?
2
2y.
y. No.
Almost. Big shot.
2y.
2y cubed. So if you expand what's going on here, this is the same as 2y cubed times 2y cubed. But these are just multiplied together too, right? Like if this is 2 times y cubed times 2 times y cubed. So I could rearrange this. I could change the order on it. I could write this as 2 times y cubed times y cubed. And without actually multiplying the numbers together, yes, I could say 2 times 2 is 4, but that's not what I'm trying to show you here. How could I rewrite 2 times 2 using exponents?
2 squared.
2 times 2 is the same as 2 squared. So,
2 squared times y 6.
and when I've got y cubed times y cubed, Bosco says yes. Add these together, I'm going to get y to the power of 6. But look at what has happened here. What have I done to get from here to here without doing all of this work? The whole point is to start to develop methods of shortcutting things. Ikshat, what are we doing? Sorry? I think I see what you're saying, and the answer is yes. Okay, so what Ikshat's saying is that 2, when there's no exponent written, that 2 has an exponent of 1, and when you've got something in brackets to a power and then to another power, the outer power gets applied inwards, but now because there's multiple things in there, it's getting applied onto everything, yeah? So that 2 is going to go there, and the 2 is going to go there, and we multiply the exponents. It's going to become 2 to the 1 times 2 is 2. Y to the 3 times 2 is 6. So what's this next one going to be? Anyone want to take a guess? Okay,
X.
hold on. Jasmine! I would like you to tell me what the next one's going to become. I want to go straight to the final answer. Garima, do you have a final answer here for me? We're shortcutting it. Dad, shortcut it. Go fast.
X4, y6.
It's x4, y6. How'd you do it?
I just multiplied y exponent by 2.
So you take the outer exponent, you apply it to all of the individual pieces, the individual bases that are getting multiplied together inside those brackets. 2 times 2 is 4, so you get x to the 4. 3 times 2 is 6, so you're going to get y to the power of 6, and you're done. The third one. We're going to be really careful with the third one. The third one is different because now you've got a negative 2. So you want to make sure that that negative 2 gets dealt with as a whole singular number. So to make sure that negative 2 gets dealt with properly, what do we need to do to the negative 2?
Make it positive.
No. You cannot just arbitrarily make it positive. How do you make sure the minus sign gets treated correctly when you're dealing with exponents?
Fraction.
No.
Negative exponent.
No.
Oh, you put a 1 in front of it.
No. Oh, because there's the 2 already there, I don't need to put a 1. We'll get to a different question. We'll get there. Think back to what we did on the very first day. What did we do to make sure that the minus sign got dealt with properly by the exponents?
We made sure that we put a bracket, the negative 1 is the negative is outside the bracket.
Well, we've got negative 2, and we want to make sure we cube that whole thing properly. So we need to make sure, this is what we need to make sure we do. That minus sign needs to be included inside of the set of brackets with the 2. So, when I go back and look at this question, if I'm going to do what we've been looking at, I'm going to apply this exponent 3 onto all of the pieces that are getting multiplied together inside there. I'm going to get negative 2 in brackets to the power of 3, and I'm going to get x to the power of 6. I need to make sure each of the pieces get the exponent. And now I want to make sure we deal with this thing properly. What is negative 2 cubed? Let's actually start to evaluate some of the number sides of things. Negative 2 cubed is, Sam, you had your hand up for a sec? No? It's negative 8. Negative 2 times negative 2, positive 4. Positive 4 times negative 2 is negative 8. So I'm going to get negative 8 x to the 6. And that is going to be my simplified final answer. What's going to happen on that bottom row? Yeah, go fast. Actually, can you wait till, hold on, Sandos. Wait till Layla gets back. No, she sits beside you. She went to get water. Wait till she gets back. And then you can go. What am I doing with no last row there? Yes.
So it's going to be 4, 2, x, y 22.
That 2, you're starting to get the hang of this, Dea. That 2, actually, I think you more than got the hang of it. You need to make sure that that outer 2 gets applied to everything. And when you've got a power to a power to a power, you multiply. So as Dea said, we're going to get 4 squared x. 3 times 2 is 6. Y to the 7 times 2 is 14. Good. Questions, comments, concerns? You with me? Or are you falling asleep last period Friday? I see lots of phones. Are we good? Okay. So here's the power of a product. The power of a product rule is multiply the outer exponent onto each, put each in capital letters, inner exponent. And now the grossest of all of them. But this one, the next one really is just an extension of the previous two. Not a coffee. So sad. Okay. Here we go. What does it mean to square a fraction? Dea.
Fraction times itself. itself.
Its action times itself. So what I'm going to get here, if I've got 2/3 squared, that's the same as 2/3 times 2/3. How do I multiply fractions together?
The numerator times the numerator and the denominator times the numerator.
Yes, you said the same thing, both of you. Good. Multiply across the top, multiply across the bottom. There's no need for common denominators. 2 times 2 over 3 times 3. But, oh, look, I'm not going to do 2 times 2 is 4 and 3 times 3 is 9. I'm not going to do that. 2 times 2 I'm going to write as 2 squared. 3 times 3 I'm going to write as 3 squared. Look what happened. I had 2/3 in brackets squared. What happened to that exponent?
The bottom side.
It got inside and went on to each piece, numerator and denominator. It went up there and it went down there. Fascinating. Let's look at the next one. Presumably the same thing's going to happen. That exponent is going to get up top and it's going to get down below. But now I've got the added little snaggle here of having another exponent in the denominator. When you've got something to a power, what am I going to do here? It's the same thing we did up here.
You're gonna multiply it.
I'm going to multiply the exponents together. So that 2 exponent is going to apply to the numerator and to the denominator. What am I going to get here?
Power 2.
2 to the power of 2 over
3 to the power of 6.
3 to the power of 6. Because I multiplied my 2 exponents together. Cool. Last 2. Brutal. I have a random minus sign just hanging out there. This is everyone's favorite thing, right? The random minus sign just hanging out front of a fraction. How do I deal with that? How did I recommend that you deal with that?
Up at the numerator.
Every single time, put it in the numerator. So we're going to bring it up top here. And to make life even worse, there are no other numbers there. It's just a random minus sign with an x squared. So to make sure you deal with these things properly, my recommendation for you is this. When there are no numbers, put a number up there too. If it's just a minus sign, what is the number that's going up there?
1.
Not 1, not 0,
Negative.
-1. So here, we're going to do this. I'm going to write this as -1 x squared over y cubed all to the 3. I'm just bringing the negative up top. And I'm adding that 1 there to make it really painfully obvious what's going on. And now this should be okay. I'm just going to do the same thing I did before. I need to make sure that that outer exponent gets applied to everything in the numerator and the denominator. That guy's going to go there, there, and there. So what am I going to get here? -1 in brackets
To the power of 3.
to the power of 3.
X to the power of 6.
I'm going to x to the power of 6 because I multiply those exponents together, and I'm going to get y to the power of
9.
9. And now there's one more step here. What is -1 cubed?
Wait, no, negative 1.
It's -1. Because it's an odd exponent. It's going to stay negative. 1 times 1 times 1 is 1. So this is going to become -1 x to the 6 over y to the 9. Same thing's going to happen down here. I'm going to have -1 in the numerator, x squared over y cubed, all to the 4. How should this one behave? Someone other than Dea. Not because I don't want to hear from you, Dea, but because I've heard from you a lot. Eve. Sondos, go ahead. Sorry, keep going, Eve. Yeah, it's going to be -1 to the power of. Here, the exponent's 4. Nope, careful. This, no, listen. This 4 gets applied to each piece. So the first thing you need to do is apply the 4 to the -1. So that's going to be 4. And then it's going to be x to the power of, multiply the exponent, 8, good. Over what? You bet. And then the last piece here, what is negative 1 to the 4? William, it's which one? You just gave me 2 answers. That's something else you guys are doing on this test that I'm marking, by the way. You guys are like, it's either this answer or it's this answer. I'm pretty sure one of them's wrong. Commit. Pick an answer and commit. It's not negative 1. I have an even number of negatives. So, William, negative 1 times negative 1 is? A negative times a negative is? Positive. So negative 1 times negative 1 is 1. 1 times negative 1 is negative 1. And then negative 1 times 1 is back to positive. So if it's positive 1, we can just get rid of it. And I'm going to be left with x to the 8 over y to the 12. And the rule here that we're going to write down is when you have the power of a quotient and you've got a bunch of stuff going on, you apply the outer exponent onto everything in the numerator and denominator. Okay, last one. When you're ready, flip the page. But we've done this last one already. We're just going to write it down properly. Dan, no stabbing, cure it with your pencil. You look like you're about to shank him. Don't do that. This is not prison. No shanking. Okay, when you're ready, flip the page. Anything to the power of 0 is? 1. Let's go straight to here. 0 power rule. Anything to the 0 is 1. So, if that's true, 2 to the 0 is 1. Thank you, William. 2 times x times y in brackets all to the power of 0 is 1. 2/3 all to the power of 0 is
1.
X to the 0 plus y to the 0?
2.
Tried to get you there. It's 2. Because x to the 0 is 1, y to the 0 is 1, and I'm adding them together. Tricky, tricky. So let's toss 2 more questions down here for you, and then you're done. Negative 2 to the 0 and negative 2 in brackets to the 0. Let's do the bottom one first. It's in brackets. So that negative is part of the base. So what's negative 2 to the power of 0? Anything to the power of 0 is?
1.
1. And that negative is included as part of the base. This is going to give you 1. Is the negative included as part of the base here?
No, what's up?
No. Yeah.
This is back to the very first day. If there's no brackets, is that minus sign included as part of the base? No. So what should this result be?
Negative 1.
It's going to be negative 1. Because if the minus sign is not included as part of the base, ignore it for a second. 2 to the 0 is 1, and then you make it negative. Okay, there is 5 minutes left. Flip to page 8 in your booklet. Here is the page I want you to start on your homework. I want you to do questions 1 to 30 odds. But the page only goes to 16, which means you need to flip it over. 1 to 13, no, Dea, it's 16, 17. 1 to 30 odds on your market set go. That's it. Have yourself a lovely long weekend. Do some math, eat some turkey, and have a good one.
For this,
When the bell goes, you may also go.